Hello friends. So today's about power. We are having all sorts of power issues. The camera battery is about 50%, the microphones are about 10%, and the boat's at about 72%. For 2 o'clock in the afternoon, that's not that great. So this next project's going to be working on addressing the power issues. So these are our 4 ampere or Li time made by Ampere lithium iron phosphate 12 volt 230 amp hour batteries. So we are going to wire them together so we maintain the 12 volt bank, because everything on the boat is designed around 12 volt. So before we do that, we need to check and see what the voltage is on each battery and get them balanced if they're out of balance. So the first one, 13.04. Second one, haha, 13.04. Third one, oh yes, 13.0454. And the fourth one, 13.04. We have winners. They are in balance with each other. That is great news. We're going to get into the workshop. So this is sort of our workshop storage. It is a bit of a mess in here, but I want to show you what we're going to be doing. Come on in. Okay. So this is underneath the cockpit, and we have this shelf right here that just so happens to be exactly the length that required for 4 of these batteries. And it's more than deep, so even though it's slightly angled, we should be able to fit all 4 batteries right there. And we have good access to the bilge and to the sidewall of the rear berth here. So we should be able to get access to the power panel and to the solar charge controller. So that's where we're going to be setting up at. So up to this point, we've been working with some pretty simple circuits with very low amperage, and so we've been able to use some of these smaller wire thicknesses. Wire thicknesses, the larger the number, the smaller the thickness of the wire. So this wire, for example, is 16 gauge, and this wire is 12 gauge. To wire our batteries, we're going to be using 1 gauge. This is what we would refer more to a battery cable. To determine which kind of cable you need to know how much amperage you're pushing and how far you're pushing it. And in a DC circuit, the distance is round trip. So whatever your distance is one way, you double it. So for us, we did the calculations, and to get to where the batteries are located to the distribution panel safely is going to use 1 gauge cabling. Obviously, these tools are no longer sufficient. Yeah, this will do. So we are going to be wiring our batteries in parallel using a bus bar, which means you combine their amperage. So in order to do it safely, you want to make sure all of your wires connect at the same length to the bus bar. So I told the person at West Marine who was cutting my cables that I needed 4 red and 4 black, all cut at exactly 1 foot. I now realize why she taped them in mated pairs. They're not all cut at 1 foot, but they do have exactly the same length mated pairs. So it looks like I'm going to need to be doing some trimming on my own. The reason for this is, let's assume that these 4 are hooked up to the battery. The energy is going to go through all of these cables equally because they're the same diameter, they're the same rating, they have all the same characteristics. But it's going to arrive at this bus bar connection milliseconds ahead of this one, and milliseconds ahead of this one, and possibly even up to a fraction to a second ahead of this one. And if we end up pulling heavy amounts, the shorter length is going to get pulled more frequently because the distance is less for the energy to travel. Over time, that's going to cause wear and tear more on the short battery than on the longer battery. So now I'm going to need to do some trimming to get these down to the exact same lengths. So this is the battery terminal. This is the screw that goes into the battery that closes the connection into the battery. That will be on one side of this cable. Then the fuse will go on the other side. And then there will be a small wire connecting from the fuse to here. And the reason we're fusing at 200 amps is these 230 amp hour batteries have a battery management system known as a BMS, and its rated draw for a hard pull is 200 amps. So we want the fuse to be at 200 amps, not at the 230, to protect that BMS, battery management system. Okay, so as you may notice, there are 6 of these on the bus bar. Additionally, we will have the solar charger coming in to give power back to the battery bank, and then we will also have a connection from this going into the power system of the boat, because this is the house battery bank. And you may notice that there's a decent size difference between the terminal posts there. So I've got to be very aware of which cable I'm wiring when, because when I wire to the bus bar, I need that cable lug. But when I wire to the battery, I need this cable lug that won't work on the bus bar. This is also the same one that will work on the large fuse. So for the short connector, we will actually have a change up where we go from the smaller lug hole size to the larger lug hole size. Now on the negative return side, we will just have the one of each on each of the black cables. So one will go to the battery and the other will go to the bus bar. Okay, so enough to fill the lug, but not a bunch of extra, so we have extra exposed. So I want to take off about that much. Let's see if I can do this without damaging my finger. Look at that fit. Nice. We're going to crimp that and then throw some heat shrink over this joint. Okay, now we're going to crimp it. Go until we can't go no more. Whoa, nice. Pressure off. I'll do a nice job. Yep, and that's why we use that heat shrink when we're done. Because I am far from perfect. Okay, we're going to turn it back on. Close the gap. Make sure it's in there nice and tight. And we're going to crimp. Oh, yes. Release. Check that out. That is solid. Okay, now just 6 more. So that is all 4 of the cables crimped. We're going to crimp up the black cables next. Okay, now all of the black cables are done. You can see the M10 connection here, the 3/8, and then the 5/16 or M8 on this side. Now for these shorter ones, it's going to be very important because they are so close together to where they connect into the fuse and the bus bar. It's going to be very important that I don't get these turned, because if one of them was out of alignment with the other, it can make screwing them down very difficult and cause some issues down the road with connections. So I'm going to make sure that these are as flat as possible when they make this connection. So you may have noticed we've changed location. Welcome to a apartment segment. There was a pretty severe storm rolling into the boatyard, so I decided to go ahead and grab all of the cables, come back to the apartment since we have a nice little workspace here, and we're gonna do the heat shrink here at the apartment. There's definitely some advantage to doing heat shrink in an air-conditioned environment. So I am going to cut strips for the large battery cables. I've got 5 so far. I need 8 total. I am wearing my headlamp, so I don't know if you can see through the table here, but Ray is trying to chase the light beam. Silly dog. Okay. So after trying the smaller heat shrink tubing, we've now moved up to the 1 inch. This may be a little bit of overkill, but we'll give it a shot and see how it does first. So I've got a trial piece here. I think I'm going to have to take the diffuser off. This stuff's just a little too big. Okay, so I would say it turned out very good, but I think I can probably decrease to about half that size and still get the desired result. Because what we're really trying to do is prevent any intrusion of water into the seam here. So I think just as long as we have enough to cover that much, we should be good. Well, heat shrinking in the air conditioning, highly recommended over not. All of our battery cables are now cut to length. All the terminal lugs have been crimped on. We've got our double wall adhesive heat shrink. We are ready to install first thing tomorrow. Welcome back, friends. We are back on the boat. It is a balmy 96 degrees outside with a heat index of 104. So the humidity is something else today. We are going to try and get everything wired up and see if we can get everything switched over to the lithium bank tonight, so that we'll be running off of the lithium power. Let's get into it. Okay, I have gotten things pulled apart. I'm gonna do a dry fit. We'll sort of loosely get things sort of tied together, so we can start figuring out placement for all of the bus bars and the fuse blocks in the battery compartment. We've laid in all of the bus bars and everything. Now it's just time to connect everything up so we can get everything talking to each other. This is going to be a chore. Let's start with the battery we already have inside. Now we're going to put the cover on. Negative plus bar. Okay. Alright, it stopped recording. This one's already connected. I'm working on this one, and these two are bent in place but still waiting to be screwed in. So let's get these wires in. Okay, friends, this has been a long road, but it's going to be so worth it when we're all done. Let me show you where we're at now. I've gotten all 4 batteries are in place. They are connected to their fuses, connected to their bus bars. We have the return line for the negative that is running to the battery meter, but we don't have the supply line for the positive yet. These need to sit overnight. Even though when we checked them they were all reading the same voltage, they need to stay connected for 12 to 24 hours to self-balance and make sure there's no small variance between the batteries that could cause a issue when we connect it to the house bank. So that's going to be it for tonight on the batteries. They are going to rest overnight, and then I will be working on running the lines to the distribution panel, and we'll get everything connected up. Well, thank you friends for watching part 2. In part 3 we'll be connecting the battery shunt, battery monitor, and a new solar charger for the solar panels. We're not replacing the panels quite yet, but we do have that coming in a future video. We'll also be adding our AC charger to help support the battery system when the solar's not quite enough. Thanks for watching. Be kind to yourself this week, and we'll look forward to getting part 3 out to you as soon as we can. Bye friends.